This unit is part of the Earth and Space Science Standard. This standard focuses on the physical features of the Earth and how they formed. This includes the interior of the Earth, the rock record, plate tectonics, and landforms. Although there may be even more information that is not in this video, we will only cover what is necessary for our standards in this video. In this unit, we will learn about Earth's interior. This video will cover the layers of the Earth, where the Earth gets its heat from, convection currents, temperature and density, seismic waves, primary and secondary waves, and the epicenter and focus of an earthquake. First, let's discuss the 4 layers of the Earth. The Earth is made up of 4 layers: the crust, the mantle, the outer core, and the inner core. The crust is the layer that humans, as well as the ocean, plants, and all other living things sit on. The crust is a solid. Below the crust is the mantle. The mantle is made up of molten magma that swirls about. Even though the mantle appears to be a liquid, in our class, we consider it to be a solid. This will make more sense when we discuss seismic waves. Below the mantle is the outer core and is the only liquid layer. The center of the Earth is where the inner core is located, which is a solid. The deeper we go into the Earth, the hotter it is. The Earth's heat comes from gravity and radioactive decay. Now let's examine density, temperature, and convection currents. Density is the amount of matter, or stuff, that is in a space. The more matter that is packed into a space, the denser it is. Things that are very dense tend to sink. On the other hand, the less matter that is packed into a space, the less dense it is. Things that are less dense tend to rise. The crust is the least dense layer, and the inner core is the most dense. You can think of the denser layers as sinking to the bottom, and the less dense layers as rising to the top. As objects heat up, they become less dense and rise. As objects start to cool down, they become more dense and sink. This continuous circulation of hotter material rising and cooler material sinking is called convection currents. Convection currents occur in the Earth's mantle. Here in the mantle, as magma heats up, it becomes less dense and rises, similar to a hot air balloon. As the magma cools down near the surface, it becomes more dense and sinks, similar to cold air falling when you open the freezer door. Convection currents are responsible for plate tectonics, continental drift, and the various plate boundaries, which are discussed in another video. Next, let's explore seismic waves. Seismic waves are waves of energy that travel through the Earth. Even though there are a handful of different types of waves, we only discuss primary waves and secondary waves. Primary waves, or P waves, are the fastest waves. They arrive first, and they can travel through solids and liquids, which means that they move through all the layers of the Earth. Secondary waves, or S waves, are slower than P waves. They arrive second, and they can only travel through solids. Because they can only move through solids, S waves only travel through the crust and the mantle. If S waves can only travel through solids, why can't they travel through the inner core, which is a solid? We experience seismic waves when there is an earthquake. The point where the earthquake starts underground is called the focus. The point on the Earth's surface directly above the focus is the epicenter. Even though that we have never been to any layer besides the crust, the composition and properties of Earth's interior are identified by the behavior of seismic waves. Scientists use seismic waves to study the inside of the Earth. As these waves travel throughout the Earth, they bounce off, speed up, or slow down when they hit the different densities of the layers. This means that we can tell what is going on inside the Earth based on the speeds and directions of seismic waves, which are recorded on a seismograph. Looking at the picture of the Earth on the right, can you figure out why the southern part of the Earth, which is the opposite of the epicenter, does not experience any S waves? You should now be familiar with the layers of the Earth, where the Earth gets its heat from, temperature and density, convection currents, seismic waves, primary and secondary waves, and the epicenter and focus of an earthquake. Thanks for watching, and we'll see you next time.